Okay, today we're going to go over some higher level factoring that you're going to use a lot in pre-calculus. I don't want you to freak out because it's not really any different than the factoring we've been reviewing with you recently. We're just going to make a couple changes for maybe a complicated trig term, but sine isn't complicated. I'm sure you guys can handle this. So real quick, we've been reviewing all the different types of factoring. X squared minus 1, that's a difference of squares. And you should be able to factor it relatively quickly. X plus 1, x minus 1. Square root of both. One with a plus, one with a minus. Well, if I change that to u squared minus 1, that shouldn't make the problem any harder. U squared is a perfect square. 1 is a perfect square, and the problem's minus, so that's difference of squares again. Square root of u squared is u. Square root of 1 is 1. 1 with the plus, 1 with a minus. So these are the answers. They're almost identical, but with a different variable. So we're going to take that same idea, and instead of using a different variable, we're going to put a trig function in it. You don't need to do anything with the trig function, so you don't need to panic. But we're going to turn it into what's called a u substitution problem. So in my next example, I see sine x and then squared. You should know that when you see it written like that, it really means sine x and then the squared on the outside. But we put that square on the word sine or sin just to show that it means the same thing. So what we're going to do is we're going to turn what looks like a hard problem into an easy problem. I'm going to let the variable u, that's just a variable we often use when we're doing substitution, I'm going to let u equal sine x. So wherever I see a sine x in my problem, I'm going to write the variable u instead. So since sine squared x is really sine x squared, I'm going to turn that into u squared, and then the problem still says minus 1. So you should recognize this as a difference of squares problem, and you should be able to factor that relatively quickly. U plus 1, u minus 1. But now, because it was a higher level problem, and we did what was called a u substitution, you can't stop there. The answer is not u plus 1, u minus 1. The question did not have a single u in it. So now you need to go through and replace those u's with what we said they stood for. So your answer is going to be sine x plus 1 and sine x minus 1. And you just factored your first higher level factoring problem. As you go on, some people don't even need to do u substitution, and that's totally fine, but I'm going to stick with it for this video. So next example, I realize I didn't number these. So next example, cosine squared theta minus 4. So I see cosine is squared. So I know I want u to equal cosine theta, the single cosine theta. If I replace cosine theta with a u in my problem, this is now u squared, because that's cosine squared, minus 4. This one, again, happens to be a difference of squares. They won't all be. See if you can factor that difference of squares problem, and then if you're comfortable, go ahead and do the u substitution. Put it back in so that the answer has cosine in it. Pause your video. Okay, so u squared minus 4, difference of squares, factors to be u plus 2, u minus 2. Don't forget that this was a u substitution problem, so you need to change the u's back to cosine theta. So cosine theta plus 2, cosine theta minus 2 is how it factors. That's where we stop. Next page. Okay, again, don't be intimidated by how it looks. I know it's got more things in it, but it doesn't make it any harder. First thing I look at, the term with the highest exponent is tangent squared. So I want u to equal tangent theta. We don't want the squared part for our u term, not in this class, not on the level we're doing. So if u is tangent theta, when I see 2 tangent squared, it's really 2u squared. When I see plus 5 tangent theta, it's really plus 5u, and then minus 3. So this is a trinomial. We've been reviewing all the different types of factoring. You might make an area diagram to factor this, but it's just a normal factoring problem right now. That's why we use u substitution to make it easier. So take a minute and whatever method you know how, see if you can factor this. Pause your video and factor that 2u squared plus 5u minus 3. Okay, so again, maybe you can factor these in your head. Maybe you know another method, but I went ahead and drew my area diagram. diamond problem factored out using all the factoring methods I've learned from previous courses and from review in this course. Now I got to 2u minus 1, u plus 3. Don't forget, it's a u substitution problem, so wherever you see a u, you need to change it back to tangent theta. So 2 tangent theta minus 1 times tangent theta plus 3. And you factored a higher level factoring problem. Next example, first thing I notice is the exponent is cubed, or more importantly, it's divisible by 3. That's how I know. Also, it's 2 terms. It's probably a cubic. 8 is a cubic, something cubed. It's a cubic number. And my exponent is cubed. So this is going to review the cubic factoring we've learned. Still a u substitution. Sine x cubed. So let's make u equal sine x. Replace the sine with a u. So it's really u cubed minus 8. Now see if you remember your cubic factoring. See if you can factor u cubed minus 8. Pause your video and see if you get the same thing as me. So remember, you cube root the first term, so that gave me u cubed rooted is just u. You cube root the second term, 8 cube rooted is just 2. The symbol stays the same, so the problem was minus, so my first parenthesis says minus. Then I take the first term in my new parenthesis and I square it. I take the 2 terms together and multiply them together. And then finally I take my last number and square it. And remember SOAP, your acronym for cubic. The first one is the same, minus. The next symbol is opposite, so plus. And the last symbol is always positive. So cubic factoring. Then, don't forget it was a u substitution problem. So go back, wherever you see a u, write sine x instead. So this factors to be sine x minus 2 times sine, remember we put the squared on the sine word, and then x plus 2 sine x plus 4. Replace every u with sine x, and you have your factored, higher level factored form. Okay, a couple more. Bigger exponents. When I look at my exponent, I just talked about how in the other problem 3 was divisible by 3. Well, 10 is divisible by 2. And they're both 10s, so they're both divisible by 2. That leads me to think this is probably a difference of squares problem. If they're divisible by 2, it's something squared. And because of the minus in the middle, it's definitely a difference of squares problem. Okay, this is the first one where I have 2 different trig functions. So I'm going to make 2 substitutions. Ready for this? So I see it's sine to the 10th, so let's make u be regular sine x, a single sine x. Because I'm using u, let's use v for the other variable. And I see tangent in the problem, so let's make v be tan x. So 2 steps, but I'm sure you can handle it. Wherever I see a sine x, I'm going to write a u. So instead of sine to the 10th, it's u to the 10th. Problem says minus. Wherever I see a tan x, I'm going to write v. So instead of tan to the 10th, it's v to the 10th. Still a difference of squares. See if you can factor that. Remember, when you're factoring difference of squares and you're square rooting something, you divide the exponent by 2. So if you don't remember that, divide exponent by 2. So difference of squares. Square root of u to the 10th is u to the 5th. Square root of v to the 10th is v to the 5th. 1 with a plus. Same thing with a minus. But now we need to go back and fix our substitutions. Every u will be sine x, and every v will be tan x. So you've got 2 variables to replace. Replace the correct variable with the correct trig function. So u to the 5th is really sine 5th times sine to the 5th x, plus v to the 5th is really tangent to the 5th x. Same thing over here, sine to the 5th x, but it's minus tangent to the fifth x. Some people don't need to do u substitution to get there, and that's perfectly fine. Next one. See if you can start this one on your own. What are you going to make u equal? What is that going to turn the problem into? And then see if you can factor it. See how far you can get on this problem on your own. So pause it. I will go to the u factorization before you come back. So don't unpause it until you get all the way to the factors with u in it. Okay, using my u substitution, it's 4u squared plus 4u plus 1. Area diagram, or however you learned how to factor that, gives me 2u plus 1 times 2u plus 1, which it's also okay to write this as 2u plus 1 squared. You should notice when they're both the same, it's common to write them as one big quantity squared. I'm going to leave mine spread out. There's no reason to do one or the other. But I'm not done because it was a u substitution problem. Change those u's to be the correct trig identity, trig expression. So 2 cosine x plus 1. You could either put a squared there or write it again. 2 cosine x plus 1. Either way, with the squared or written twice is perfectly fine. Next slide. See if you can start the first example on this page. So what are you going to have u equal? What does that turn the problem into? And see if you can factor it with the u's. Pause your video. Okay, so u needed to be tangent theta. Turns the problem into u squared plus 2u minus 15. Normal trinomial factoring gives me u minus 3, u plus 5. Don't forget to change the u's back to tangent theta. Tangent theta minus 3 times tangent theta plus 5. See what you can do with the next example. Actually, before you go too far with the next example, I need to make a change. Those should have been to the third power. Sorry about that. So, when I look at my exponents, I see that they're 3's, so cubic. And then since it's a minus in the middle, it's a difference of cubes. So when I go to start factoring it, I'm going to use my difference of cubes. 2 different trig functions. So again, u and v. So u can equal cosine theta, and v can equal tan theta. Replace it in your equation. So it's really just saying u cubed minus v cubed. And then see if you can factor that. Pause your video and see if you can factor that. Okay, so u cubed minus v cubed factors to be u minus v times u squared plus uv plus v squared. Now go back and replace the correct variables with the correct trig functions. So instead of u, probably need to start over here, it'll say cosine theta. Problem says minus. Instead of v, it'll say tan theta. And then the next one, instead of u squared, it'll say cosine squared theta plus, multiply them together, so that's just cosine theta, tan theta, plus, and then v is actually tan, and it's squared theta. Hopefully you guys are catching on. On the next slide, I just want you to try them on your own. Pause the video, and then when you unpause it, I will show you the answers. So here is our next slide. Just 2 problems for you to work on. I'll do them one at a time, so why don't you try number 1 first, and then when you unpause the video, I will go through my solution to number 1. Pause your video. Okay, u is cosine theta. Turns the problem into 2u squared minus 7u plus 5. Factored out is u minus 1 times 2u minus 5. Also remember, for all factoring problems, it doesn't matter if you have that parenthesis over here and the other parenthesis over there. As long as the numbers are in the same factor together and inside the parentheses looks the same, you can swap the order of the 2 parentheses. Then replacing u with cosine theta, I get cosine theta minus 1 times 2 cosine theta minus 5. See if you can do our last one on your own. Pause your video. Okay, 2 trig functions. So u equals tangent theta and v equals cosine theta. Turns the problem into 4u squared minus v squared. factors to be 2u plus v, 2u minus v, because it's a difference of squares. Back with the u substitution, u was tangent, v was cosine. So wherever I see a v, I'll change it to a cosine. Wherever I see a u, I'll change it to a tan. Gives me an answer of 2 tan theta plus cosine theta times 2 tan theta minus cosine theta. So this is our higher level factoring that we will use a ton in pre-calculus next year.